Okay, we're 3 minutes over. I think that's sufficient. Again, just a disclaimer, everyone, these videos are recorded. So just know that if your company has a policy for your name not showing up on a recording, um, that's something that you need to be cautious of. But we hope to upload these to YouTube just like we did with last month's, so that for all of our friends who are out on PTO or just stuck in other meetings and don't have the ability to attend, they can go back and watch the videos. And obviously, for those of you that maybe didn't catch everything the first time around or just wanted a refresher, those videos are there for you as well. So with that, let me just, again, thanks everybody for joining. My name is Calvin Remsberg. I'm a sales engineer here at Juniper Networks. And this is a continuation of our monthly automation workshop. The goal of these workshops is to focus in on the fundamentals of network automation, specific topics, and to go pretty deep on those fundamentals. That's kind of the best way that I feel that I learned network automation, was just tuning in onto what were the specific things that I really needed to worry about, and then continue to develop the muscle to be able to execute on those things. Now, today's presentation, we're going to be focusing on Ansible. And if you haven't heard of Ansible before, don't worry, we're going to be covering just a little bit of those basics as well. But for everyone else that has been within this automation space, you've probably seen Ansible mentioned 1 or 2 times. You probably have some tertiary understanding as to what the product is and what it's going to accomplish. But even with that, we'll still drill down, again, the basic overview of the product. We're going to look at this from a vendor agnostic perspective. I don't want to ever come off as like saying, one vendor is right or the other. And we're going to be doing the same showcase here with these tools that we highlight, in this month being specifically Ansible. So with that, let's go ahead and start the presentation. Let's see. Here we are. And giving away all my slides ahead of the place. Okay. So an introduction to Ansible for network engineers. One of the things that I really enjoy about Ansible is just how large the breadth of the project is and how many different areas of the IT environment that it can play a role in. But one of the things that I wish I saw a little bit more of was a more networking engineer perspective, because for a lot of us coming from traditional operations on the customer side, we've got a lot of things already going on for us, a lot of different projects, a lot of timelines, operations, etc. And to find finely tuned training for network engineers is sometimes pretty difficult, and you'll be spending a lot of your time figuring out, okay, here's how Ansible works, but maybe in the context of server administration, which ultimately doesn't play to any of our strengths. So for this presentation, we're going to be focusing on where Ansible fits in for the network automation perspective. All right, we've got a big agenda for today. Again, the first part, I want to highlight just the basics of Ansible, where it came from, where it's going, what was its focus originally, has that focus shifted since then? And then I'm also going to be talking about the value of automation frameworks, which Ansible is kind of grouped into that categorization as an automation framework. So we want to talk a little bit about what's the value proposition with the automation frameworks. When would you choose to use one and when you wouldn't? And after we have just the basic understanding of the lay of the land, then we're going to dive into the essentials of Ansible. And this is where we're going to be spending most of the time of our conversation today, is focusing in on those core concepts of Ansible. And so there will be quite a bit of content right there. Excuse me, as my mouse is jumping all over the screen, I'm trying to admit my friends into the meeting. After we cover the essentials of Ansible, we'll talk just briefly about Ansible Tower and Ansible AWX, how they're different, how they're the same, and what kind of value that those solutions also bring to the table. Let me see here, admit. Okay. And after we go through that, we're going to wrap up our content training, the educational aspect of this, and we're going to focus in on the strengths and weaknesses of Ansible. What does it bring to the table? what are some of the positives of working within Ansible, and then what are the weaknesses of it. And then we're going to be spending the rest of our time focusing on several different live automation demonstrations. And so we'll touch upon those in a second. But what to expect from this session, and specifically what to expect with like a presentation from me, before I start listening these things off, I just want you to have an understanding that my style of presentation is more like my background is doing live streams of coding on Twitch and networking. So I typically deliver the content very quickly, but I'm also very accustomed to being interrupted. So if you would like to ask a question, feel free to pipe up. Use the chat as you see fit. I think there's a raise hand function inside of Zoom. Feel free to use that. I'll try to get to it. If it's like a burning question that you just have to have answered, feel free to unmute yourself and go ahead and pipe up. I'll be trying to check the chat as I go throughout this process. The time that I like to spend, I like to spend about half of our time today, which is going to be 2 hours, maybe even more if we get carried away. But I like to spend half the time on the actual content, just to kind of give everybody on the same page, and then focus the rest of the presentation on live demonstrations. And we will be sharing the code examples of all the projects, and actually a lot more. We'll be sharing those code examples at the end of this presentation. So if you'd like to go and replicate this environment within your own personal lab or your lab at work, everything will be there and ready for you as well. All right, so with that being said, let's dig into the Ansible topic here. So what is Ansible and what is the project? What were the goals of this solution? So you should know right off the bat, Ansible is a open source automation framework. We'll talk a little bit about those last two words just in a second, but it is maintained by Red Hat, which is now a part of the IBM family. And more interestingly to note, probably for our conversation today, is that the original scope of Ansible was on server automation, which kind of makes sense when you think about it. Red Hat being a Linux company, they also needed something to help manage the infrastructure. And so when the project was originally created in 2012, it then was enveloped by Ansible, I'm sorry, by Red Hat back in, I think 2015 was around the time. Now, since that time, actually, rather quickly after that acquisition actually took place, Ansible projects started to shift to other areas outside of server administration. And one of those was networking. And we'll talk a little bit about this later, but you should know that one of the things that really kind of forced Red Hat to start pivoting into networking is one of the biggest strengths about Ansible applies to us network engineers. And that is that the product doesn't have any kind of agent that runs on the device. And the transport that it uses to communicate to the remote devices, our routers and our switches, et cetera, is SSH. So right out of the gate, every networking device is effectively Ansible ready because we already use SSH because we're good engineers and we don't use Telnet anymore. And there's no additional ports to open up. You get the inherent role-based authentication that we would have with the configuration on the devices. So there's a lot of really good reasons as to why the networking world was kind of really forcing Ansible to shift and focus on networking. Now it's still more than just networking, but this is a common thread that you'll see in network automation world. Networking engineers will look to the DevOps world, they'll look to the server world, and they'll find some kind of tool or process that could work in the networking world, and we'll port it to work for us. And that's kind of the case here with Ansible. Now, the goals of the Ansible project, one, it's got to be really easy to understand. There's a lot of Python that goes on in the background, but can we provide an abstraction on top of that Python to make it more easy to consume, if you will? And so Ansible achieves this by leveraging a markdown language called YAML, which you have an example on the right side of your screen right now of what that YAML actually looks like. So it's rather easy to understand. It's rather intuitive. to figure out kind of what things are happening within there. So simplicity is a really big selling point within Ansible. Another thing, it's really, really simple to install. Just takes a single command to actually install Ansible on your machine. And again, it's just extremely easy to kind of get off the ground and running with. And one other thing that's just worth noting about Ansible, and honestly, this applies to most automation frameworks as well, is that Ansible project itself, you will ultimately run into a situation where Ansible just, it's a little bit convoluted, or it's not accomplishing exactly the goal that you're looking for. You can actually extend Ansible if your Python skills are up to par, and you can actually build additional functionality into the product and reintroduce it back into the public so others can enjoy that. So that extensibility is a really attractive aspect within Ansible. Now, I did mention that Ansible is an automation framework. So let's talk really quick about what an automation framework's goal is. What is a typical automation framework composed of? And what are some of the additional automation frameworks that you might see out there today for network engineers? Well, if anything, I want you to walk away with one understanding. The goal of an automation framework, and this is not an official definition by any means, this is just my perception. The goal of an automation framework is to make automation easier. That's it. That's the whole aspect and value proposition that we get with an automation framework. So now that we know the primary goal of an automation framework, well, what is it actually composed of? What does it actually look like? Well, an automation framework will bring certain components into your environment that will make life with automation just a lot easier to work with. And so if we just focus right here, like on this green box on the screen, these are the core components that are typically found within an automation framework. One, they have some type of mechanism that allows you to build inventory, either by statically creating files where you literally type in the host name and the IP of the device, or through dynamic inventory sources like pulling in from your network source of truth, like Nautobot, or through SolarWinds, or maybe an IPAM. The idea is to store as much of your inventory inside of a remote system so that your automation framework can ingest it and then make it easy to actually build automation against that. Another really key component is plugin ecosystem. Again, kind of like we mentioned earlier about the extensibility, an automation framework will typically allow a developer, a seasoned developer, to build additional functionality into the product. And we'll see a lot of those plugins with Ansible actually being developed by networking vendors like Juniper. Another great thing an automation framework will take care of, they will obviously take care of the actual execution of your task, whatever it is you're looking to accomplish. It will help manage the SSH connection to a remote device, help run certain commands, grab the output of those commands and present it to you in a way that's consumable. So automation is obviously bound to the hip of the execution engine, but those come in different flavors based on the actual automation framework that you're using. And another really important thing that I think is sometimes overlooked is how to handle the results. So think of this as, I'm going to do a lot of automation against 20 networking devices. And if I was to watch that automation, whether it's a playbook, an Ansible, or a Python script in Nornir or something along those lines, there's going to be a lot of output and a lot of results, but depending on the type of task that I'm performing. An automation framework will many times provide mechanisms to send that data to a remote system like Slack or Microsoft Teams or an email, or maybe send the results to a remote web API that your team has built so that you can view them later. So the results engine is really about building this type of auditing and results of your playbook task so that everyone has visibility within there. Now, some of the more common automation frameworks that we see today, by far, it's Ansible. Almost everywhere starts at least with Ansible. And sometimes when they find that either either Ansible isn't the right fit for one reason or the other. There's many, many reasons, and every customer has their own perception as to whether or not it's fit for purpose. We'll start to see customers try other automation frameworks out there. Nornir is an up and coming automation framework. It's built by the primary developers. Also created a Python package called Napalm, and another one, Kirk Byers, created NetMiko. And there's other really great people that have also contributed heavily to this project. But Nornir is a pure Python automation framework. There's no YAML abstraction. It's meant for Python developers to do things very, very quickly. And another one that you'll see out there is NetPalm. NetPalm is also another up and coming network automation framework. Its whole concept is to effectively act as a REST API broker for all of your network automation. Now, if you attended our session last month, you'll know that a REST API is an HTTP-based API. Think of NetPalm as a web API that lives within your environment that can translate your task into SSH commands running on network devices and then getting the feedback back. So NetPalm is a really great tool that can help you interact or build intuitive web applications and basing it off of that. But we're here to talk about Ansible. So let's dig into the core components of Ansible. And some of these are going to look very similar to the slides that we just viewed. Within Ansible, we have 4 major components, one of which is kind of nested within the other, not to confuse you, but we'll talk about that just in a second. But we have the inventory concept, just like we did with the other automation frameworks. We have this concept of playbooks, and playbooks are going to be where we actually construct all of our automation tasks within there. Ansible also provides this construct of a configuration file, which enables you to change the default behavior of Ansible. I'll show you some examples here just in a second, but just know that when Ansible ships out, it ships out with hundreds of default settings. And a lot of those default settings are, again, more tailored to the server infrastructure world. So for the networking side, we'll probably need to make a little bit of adjustments, and we do that by editing this configuration file. The last thing I just want to talk about really quickly is the Ansible modules. This is that plugin ecosystem. These are the actual Python scripts that are running in the background. So whenever we take a look at the Ansible playbooks, we'll see the modules being referenced within those playbooks. And just know that whenever you see the name of that module, it's literally asking for a Python script by that name to be executed. And that might not make a whole lot of sense just yet because you haven't actually seen an example, but let's get into each one of these components just a little bit deeper. So within the Ansible inventory, and now again, this construct can be statically typed out like I have here on the screen, or it can be sourced from a remote endpoint, something like a network source of truth, like Nautobot, Netbox, Infoblocks, any of those types of things. As long as there's an API on there, you can build a dynamic inventory source from. For the most part, not all APIs are created equally. Now within Ansible, I'm going to be showcasing a lot of examples just with static files, because that's honestly where most people start their network automation journey with Ansible. They don't want to start building Python scripts to do dynamic inventory. It's a little bit more of an advanced topic. So for today, we're just going to focusing in on Ansible inventory files. Now the inventory files is kind of interesting with Ansible because it can be structured in 2 different formats. In the example that I'm showing here, I'm using a format called YAML, which everything else in Ansible is typically based on this YAML structure. And for me, it makes a little bit more sense when I start to build out logical groupings. I can see that I've got the host actually listed here, and it's obvious what group that they're nested within. So Austin Spine 1 is nested within the Spine group. Austin Leaf 4 is nested within the Leaf group, etc. But there's also another file format that you might see used in place of YAML, and that is an INI format. Now, I don't have an example for you. Actually, it's not entirely true. I have an example of an INI file, We'll showcase that in just a second, but just know that when you're working with Ansible, you might see it structured in one or two ways when working with static inventories. And again, as we can see here on this example, we are enabled to create not just the host devices and assigned like IPs and such to them, but again, we can nest those hosts into groups, which then enables us to just reference an entire group to do automation on in comparison to just a single host. Now, the Ansible playbook itself, this is where all the money is made, right? This is all the automation is executed within here. Don't do automation within the inventory file. The automation does not come from the config file. It's right here within the playbook. So let's decrypt some of the things that we're seeing on the screen so it can maybe make a little bit more sense to those that have never seen this before. At the very top of your playbook, first of all, we recognize that the file format is in a YAML structure. Now, if you've never seen YAML before, know that YAML is kind of like an abstraction on top of JSON. And if you don't know what JSON is, well, that probably doesn't help either. But know that the two are kind of bound to the hip. And YAML is really there to help us understand and interpret data in a structure that's fairly easy to consume, as opposed to JSON, which arguably is pretty easy to consume, but maybe a little intimidating if you haven't really been in this automation space before. So YAML is a little bit more friendly, and this again is the primary data format that Ansible uses. At the top of our playbook, what we see on lines 1 through 6 here, we're defining how we want our play executed. We're not specifying the actual things we're going to do, but we're kind of setting the ground rules so that Ansible knows what devices we want to automate and if there's any additional things that we need to import. Now, in my example here on line 1, I see that I'm importing, or I'm going to be using this automation against a single device with the device's name is Dallas Firewall 1. The next three lines are a little bit confusing. Just bear with me just for a second. When I talked earlier about how Ansible is originally focused in on server automation, there are a few things that we need to change within Ansible to make it work a little bit better with networking devices. And this is where lines 2 through 4 come in. Now, line 2 is a really interesting one because it fundamentally changes how Ansible works. If you remember earlier, I said one of the key selling points of Ansible is that it's based on SSH, which is enabled on all of our devices and servers. Now, the thing I didn't mention about that is Ansible's default behavior is it will take all of the tasks within the play and it will create a dedicated Python script for each one of your servers, and it will secure copy that Python script over to the remote server where it'll actually execute the task, get the output, and then send it back over to the Ansible controller. Now, in a distributed systems world, that makes a lot of sense. That lets Ansible operate at a lower resource reservation, right? Because it's not doing all the work. It's actually punting the heavy lifting to the remote devices to do through this Python script. Now, in the networking world, we know that even if your networking device supports Python, you just can't copy Python files over there and execute them willy-nilly. The networking vendors have effectively put up walled gardens around, or sandboxes, however we want to call them, sandboxes around the Python runtime. And we limit the types of packages. So effectively, that mechanism of Ansible creating a Python file and pushing it to the remote device, it doesn't really work well for us in the networking world. So on line 2, I specify connection local to tell Ansible, hey, Ansible, don't try to take this task and wrap it into a Python file and send it to my router, because that router is not going to know what to do with it. Instead, go ahead and issue these tasks locally. So that's kind of where that connection local comes from. Now, gather facts is also a more a server thing. And it almost, I mean, it makes a lot of sense for us on the networking side, but there's a couple things that are just a little bit different. And what I mean by that is that gather facts is basically Ansible's way of doing like a show version on a server, right? And it gets a ton of information about that server, all of its interfaces, all of its IP addresses, all the packages installed, et cetera. Sounds great for a server administrator, and you would definitely want to keep gather facts to true if you are doing server automation. But again, for networking, that type of functionality isn't really there. There's some things being done in the background inside of Ansible project to provide like a gather facts functionality, which on our devices would be like a show version or show chassis inventory or whatever it might be. But for right now, gather facts is set to false, and so that we don't try to get Ansible to perform that functionality. And the last one I'll just talk about is line number 4, become equals false. When we get to the weaknesses, I'll talk about one of my annoyances with the Ansible project. But essentially, what become equals false means to the server world is request super user access to the device. In the networking world, that construct isn't there, not really in the same way that it is on the server world. Now, good news is that lines 2 through 4, they're kind of confusing, especially to people just getting started with Ansible. These are really good options to include inside of an Ansible config file so that you never have to worry about them again. So you can take some of this functionality that we're overriding here in our playbook, and you can punt that to a configuration file so that you never have to worry about setting these settings inside of your playbook. Lines 5 through 6, what we're seeing here is we're actually importing third-party modules into our playbook. In this case, I'm importing the official supported Ansible modules for Juniper, and that is found on Ansible Galaxy at the path of juniper.junos. Now, we'll talk a little bit about this later when we talk about strengths and weaknesses, but just know that right now, Ansible is kind of in an inflection point within the project. It's making a big transition. And so you'll start to see you'll start to see things like collections referenced more and more throughout there instead of roles. But know that just collections is kind of like an abstraction on top of roles. Roles will ultimately fit inside a collection. So you may or may not see roles referenced like this in the future. It might just be referencing collections. Now, lines 7 through 20, this is where we're actually doing the automation task. This is the nitty-gritty execution that's taking place. Now, what we see here is I've got actually, before I start explaining, let's shift to the next slide, because that's going to be addressing exactly this next topic here. And that is the Ansible module. Now, you can think of a module like a plugin. It's literally a Python script in the backend. So anytime you type out the name of a module, which in my case, the name of that module is Juniper_Junos_RPC. There is literally a Python script in the background with that name on it, which has a bunch of Python code that tells the script how to function. Now, everything else that's nested within, like we can see like this level of indentation, anything that's nested within this module is actually just an argument that we're sending to the Python script. So this is Ansible's way, if we had to kind of step back and subtract ourselves from the deep level, just know we're calling a Python script called Juniper_Junos_RPC. We imported that Python script by calling in these roles that we mentioned up here on lines 5 through 6. And we're passing into that script a series of information. One of them is, where is my host at? What is the username for this device? What is their password? Obviously, you would want to secure these in a little bit better fashion than I'm showcasing here. But and we're passing in one other argument, and I'm saying the RPC, remote procedure call, if you remember last month's session on the netconf API, we're passing in an RPC saying get route information. This is basically saying show route on your device. So again, the module itself, the Ansible module, is literally the Python script in the background. This is you interfacing with Python, but by using a different file structure, the Ansible YAML markdown language, in order to actually execute that Python script. Now, Ansible ships, it used to ship with thousands of modules. I don't think that's an exaggeration. It got kind of crazy there for a while, and some of us in the networking world are at fault for that. So let me subtract this just for a second and talk about where Ansible is and why the module construct is slightly changing. It used to be up until Ansible version 2.9, which was very recent a release. The network vendor modules would ship out with Ansible themselves. So Ansible would maintain the vendor modules like Cisco, Fortinet. Ansible would produce modules for Juniper devices as well. And over time, network vendors would continue to kind of flood Ansible with new modules. One vendor, I'm not going to mention by name, has over 400 different modules to select from. It's 400 different Python scripts that needed to be validated and maintained by Red Hat. And ultimately, Red Hat decided to subtract all the vendor modules from the core project. This is that kind of inflection point that we're talking about. So going forward, you're going to be importing your vendor modules either through the construct of roles like we're showcasing here, or the higher level abstraction layer, which we call collections. So just know that if you're familiar with how Ansible was up until like a year ago, know that that's going to slightly change, because Ansible is going to require the customer to download and install the collections rather than them maintaining it. And honestly, I can't really argue with that logic. I wouldn't want to maintain thousands of scripts from different vendors. That just doesn't scale. Okay, the last thing I'll just talk about on this playbook is we're storing the output of our task in a new variable that I'm calling route table. Now, Ansible has chosen to reference that task, basically creating a new object or create a new variable. They refer to that as register. So whenever you see register used within a playbook, know that that means that the output of the task is going to be stored in a new object called whatever variable is called. In this case, it's route table. And then we can use that object in a later task to print it out to the screen so that everyone has visibility and understanding as to what's actually being executed. The last aspect of Ansible that's worth just double clicking in on is the configuration file. Again, this is an INI structure. So in contrast to everything else that we've seen today, which was YAML based, the Ansible configuration file is still in an INI format, and it's quite easy to understand what's going on. We have a set group of defaults, and then in order to override some of those defaults, we will type in whatever value or whatever variable we're trying to change, and then write in our overriding aspect into it. And so to help kind of understand a little bit of that, I'm showcasing here in this example a couple of things that I always do inside of my Ansible config file. And so we'll just talk about them a little bit, because that'll help you understand, or at least I hope it'll help you understand a little bit of how Ansible thinks and how it operates. So lines 2 through 3 that I've got listed here, these are to really deal with SSH, to be honest with you. We all know if you're on a machine and you want to SSH to another device, either through PuTTY or secure CRT, if your host machine, your computer, your laptop, your workstation, if it's never seen the public key of the remote device before, it'll ask you to accept it. And if that public key was to change, your local machine will complain and say, wait a minute, you used to be SSHing to this device that had this public and private key pair, but that is no longer the case. There's a new key pair on there and we don't trust it. So those are some of the default behaviors of just SSH itself. Lines 2 through 3 allows us to tell Ansible, hey, I want you to kind of relax some of those rules. So line 2 says, first of all, never check to see whether the remote device's public key is the same one that I saw last time. Just never do it. Now, obviously, for that, you'd want to make sure that that's blessed and ordained within your company security posture, that you're okay with that type of overwrite. Me and my lab, yeah, sure, why not? I change IPs and host names all the time, so that's just kosher. Now, line 3 is host key auto add equals to true. That is kind of exactly what it sounds like. When you talk to a remote device for the first time and you see its public key, your machine will automatically add it to your list of known host, which will be in your SSH configuration path at a file called known host. It'll automatically do that so that you're never prompted again, do you know this remote device? Line 4 is a really, really interesting thing for 2 reasons. One, it's another example of Ansible using words that I disagree with. And 2, it definitely highlights some of the performance tweaking mechanisms that you can do with Ansible. And if that second description didn't give away what this functionality is, let's kind of explain it just in a little bit more detail. Forks is what allows, or is what instructs Ansible how many parallel job tasks that can be executed at the same time. Now, if I had set the fork value to 1, and by the way, the default, I believe, is 15. But if I had set the fork limit to 1, let's go back to that example where I had 20 devices that I wanted to automate. It would log into the first device in the inventory. It would execute the task, get the feedback, report the feedback back to Ansible, log out of that device, and then go to the next device in the list. It's a serial fashion, right? It's not performing the same task in parallel. And that's what Forks allows you to do. It allows you to take a single task and say, I want to execute this task at 15 times, or at least 15, or at the most 15 times, so that if it were doing 20 devices of inventory, it'll first log into the first 15 within the inventory file, performance task, and then as devices are completed, new connections will be built to another one. So that's kind of the construct of Forks. Another really interesting one, just to note, is line number 9, where I statically tell Ansible where I would like my configuration, or I'm sorry, where I would like my inventory file to be located. If there is a default path for an Ansible inventory file, but what's most common is that we'll see every project will have its own dedicated inventory file, or hopefully you can get to a point where you're actually using dynamic inventory. So I saw that we had a question, and this is actually a really good stopping point. So let's go ahead and see that we have it. Mark asked, are the lines we're looking at a part of Ansible or a part of the Juniper.Junos module? Let me make sure my timestamp is right. Yeah, so this is the current slide that we're looking at. What we're actually looking at is not the Juniper.Junos. What we're looking at here is an Ansible configuration file. Now, you may never see this if you're using Ansible Tower, where configuration files can be set within there as well. And we'll talk a little bit about Ansible Tower in a second, but what we're actually looking at is if we're running Ansible on our local machine or remote server, there needs to be this construct of a configuration file to enable you to manipulate some of the default behaviors of Ansible. And that's what we're looking at right here. Now, the configuration file can, again, be stored in a default path like etc Ansible config. But most commonly, at least from what I've seen within the field, is every project will have its own dedicated Ansible config file that we'll use to address that specific project. So good question, Mark. I hope that makes sense. So config files are built from the built-in Ansible function, if I understand it correctly. Yeah, the config file, first of all, there doesn't have to be a config file in your project. It could just default to the default path for the Ansible config file. But if you would like to have per project mechanisms of overriding some of the default behavior, then that's where you would start to look to build your Ansible config file. And honestly, you will not be building and editing configuration files frequently. What I've tend to have done is over the years, whenever I start a new project, I copy the Ansible config file from my last project, and I just over the years, I'll tweak values here and there, but I pretty much have a golden template that I'll use for all of my Ansible config files. So it's not something that you'll do quite often. Now, I saw that we also had another question. Someone in the chat had raised their hand, and I don't think I can see who that was. So,
That's all right, Calvin.
Jason.
Yeah, hi.
Yeah, go ahead.
I just wanted to know how much of this is predefined, what we're looking at, and how often, how much when we go in and we want to play with these scripts or INI files, can we use the defaults, or do we really have to walk through step by step?
You don't have to use the defaults. I'm sorry, you don't have to make changes to the defaults. Now, in my case, these are some of the things that I see that are really common. The SSH key management and specifying where the inventory file is. But even you can still use Ansible and never think about the configuration file until you need to think about the Ansible config file. So you can get off the ground and running, but when you start to stub your toe based on some of the defaults that Ansible has, and you'll know, and I'll show you an example of what like a failed situation is where you need to actually get into a config file to make an adjustment. We have that within one of the examples. So again, the majority of your time will not be spent in the config file. It will be spent in the playbooks actually building the automation. You'll probably come to a point where you have like one Ansible config file that you use for all of your projects so that you never really have to think about it until you really need to think about it. Does that help, Jason?
That's great. Thanks.
Good. Good questions. Good questions. Keep them coming, everybody. All right. Now that we know about Ansible, we know the core concepts, right? We know that there's 4 fundamental things that we'll need to consider. One is the inventory. Then there's the actual Ansible playbook. There's the modules that we need to call within the playbook. And then if we run into an issue with some of the defaults of Ansible, we need to know how to override them. Let's now talk about Ansible Tower or Ansible AWX. And you should know that I'm going to be using these words interchangeably. I'm sorry, they're technically the same, but they're technically unique. So with that little bit of confusion, let's talk about what Ansible Tower and AWX bring to the table and why there might be a little bit of confusion with them. So we know with Ansible, we get these core concepts, right? We get the inventory playbook, modules, config files, everything that we just listed out. Now, there's other aspects that customers have typically wanted to do within Ansible. One of those is to leverage a web user interface, a GUI. The customers don't always work on a Linux machine, which, by the way, is a default requirement of Ansible, is to be on some kind of Unix or Linux-based machine because of the way that the project is structured. So if you're not, and you still need to do Ansible execution, well, having a web user interface is pretty attractive. It also helps put oven mitts on the hands of network engineers, makes them click rather than type things out. And in Ansible Tower, there's a little rocket ship that's just it's a lot of fun to click that rather than actually typing out Ansible-playbook, et cetera. So the web user interface is definitely a very big value proposition of Ansible AWX. One of the other things that it brings to the table is a REST API. So once you start getting further down in your automation story, you'll ultimately even want to subtract the web user interface. And you might want to say, I want to execute Ansible from a remote system, or I want this playbook to execute whenever ServiceNow sends a command to it. And so the REST API is really the unsung MVP of Ansible. And it's one of the things that helps separate it from competing technologies like Nornir as of today, where there is no REST API interface. Again, if you're unfamiliar with REST API, we talked about it extensively in last month's session. Feel free to go back on the YouTube. Now, on another thing that you get within the web user interface. And this is really important when you start thinking about it in the context of working inside of a team environment. Ansible Tower will give you user permissions, give you that AAA that we all love, right? The role-based authentication, and you can tie into external sources like Active Directory or some other kind of LDAP system or some other kind of authentication system. So to have the ability to automatically permit users and assign permissions based on, maybe an Active Directory grouping or something is very, very advantageous, so that you're not playing the game of managing user accounts inside of Ansible. That's never fun. The other point, though, is killer, and that is the concept of having an audit log, so that everyone on your team can go back. They can view the history of a playbook, whether it was successful, whether it failed, what were the variables that were passed into that playbook, what was the result coming back from the remote device. And again, who issued what commands on what devices at what time. That kind of historical construct doesn't exist natively within Ansible, the Ansible core project, because you'd be issuing it on your own computer from your own home directory, and no one would ever know any of the wiser. So to have that kind of audit log is extremely beneficial. So I've confused the words quite a bit of Ansible AWX and Ansible Tower. Let's talk about just the separation and why they're still kind of the same thing. If you've played in the Linux world for a while, you'll know that Red Hat has this mechanism of software delivery, and that is they have a distribution, Red Hat Enterprise Linux, that is the supported Linux distribution that you pay Red Hat for that support. There's licenses, there's subscriptions, there's all these great things. And then when Ansible or when Red Hat wants to produce new features or enhance their operating system, they do that in what's called an upstream release, which is now Fedora exclusively. And honestly, Fedora was always the one. Not going to get into CentOS conversation here, but all of the work for Red Hat Enterprise Linux is actually done in a different operating system called Fedora. And then all the bugs are worked out. And then once the packages are rock solid and ready to be put into the supported version, then they'll move those packages and constructs over into Red Hat Enterprise Linux. The same is true for Ansible Tower. Ansible Tower is the paid supported version of everything that we just talked about, the GUI, the REST API, users, and audit log, etc. However, there is an upstream release where all the development for Tower goes into, and that's called Ansible AWX. Ansible AWX is completely open source and allows the community, as well as obviously the developers themselves, to actually contribute into the product that will ultimately become Ansible Tower. So just a quick note, Ansible Tower is the licensed product. That's the way that Red Hat makes money, and they definitely deserve to make money for this product because it is outstanding. However, with that being said, what I have seen more oftentimes than not is that customers will start, networking customers, and I'm not focused on the other parts of IT, but networking customers will start with Ansible Tower because we're used to having the requirement to get support from a vendor, et cetera, et cetera. For one reason or the other, either it's because the delegation of responsibilities of managing Ansible is sometimes complicates IT teams and how they're grouped. Sometimes the problem is licensing, because the licensing scheme for Tower has not always been friendly for networking devices. For one reason or the other, most companies, when they start with Ansible Tower, within a year or two, they decide that they want to go the AWX route, and it enables them to have a little bit more. Oh, let's see, we got one person coming in, but allows them to deploy more instances of AWX. There's no licensing concerns, et cetera, but you're on your own as far as support goes with AWX. So you're not entirely on your own. Ansible has an amazing community, but just know that you're going to deal with some of the development bugs that they're working through as the product moves into Ansible Tower. Now, in my use case, I'm using AWX because I'm on a personal budget, but I also I prefer the way that Ansible AWX is built and maintained through Docker containers. I think it's really slick. So, but just know you may see Tower, you may see AWX, you may see them called the same thing, and they kind of are, but they're also kind of unique. So just understand the differentiation between there. Okay, let's see here. The strengths and weaknesses of Ansible. This should be a fun one. Again, one of the core constructs of Ansible is that there is no agent that requires to be installed on the remote device. And for networking devices, that is an absolute blessing. Previously, we saw products like Puppet trying to get into the network automation space, and they required an agent to be installed on the remote device. That's always difficult, not only to actually get it blessed by your organization to run these agents on networking devices, but they can typically be difficult to maintain. There's a life cycle management you have to worry about. So to not have a requirement for an agent to run on a device enables Ansible to effectively automate really any device as long as it's SSH reachable. And that's another one of the core constructs, again, of Ansible, and it's definitely a strength for us in the networking space, is that its primary focus is on SSH transport. Now, that is not to say or give the impression that you cannot do things with a REST API. You can absolutely do that. You can pull in PowerShell. You can do all kinds of great things with Ansible. It doesn't have to be SSH, but that is the default connection mechanism that Ansible will use. And so for us in the networking space, it's already enabled on our box. We already got user permissions assigned based on AAA rules and policies. So that's an absolute blessing for us. Now, the second one is interesting. Modules are typically idempotent. Now, before you start Googling, what the heck does that weird word mean? Let's talk about it just quickly and why I say typically. Idempotency is this concept that says, we're going to be making a network automation change. If that change is already present on the box, then don't push the change to the box. Just move on. So think about this, like if I've got a firewall and that firewall's name is Ansible Firewall 1, and then I've got an Ansible task that says, hey, log into that firewall and change its host name to Ansible Firewall 1. Ansible, when it logs in there, it will do a quick check based on the way that the module is constructed. It'll check to say, is the host name already Ansible Firewall 1? And if it is, back out. Just don't do anything. Now, in the networking world, this is extremely valuable because there are some network operating systems out there that aren't driven through an API. They're literal screen scraping where they're sending SSH commands. And those devices that aren't built through an API, they have the unfortunate reality that if you log into that box and you paste in a configuration, even if that configuration is already on the box, there's a good likelihood that you'll have like some kind of control plane adjacency flap or something along those lines. If you've ever logged into like config T, I'm not going to say any vendors by name, but like if you did config T and pasted in router BGP, blah, 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 even if you pasted in the exact configuration that was already on the box, there are times that I have seen that will actually cause an adjacency flap on the networking devices. So it was a futile attempt to begin with, right? We're trying to make configuration changes. They're already present on the device. And oh, by the way, we just flapped our BGP adjacencies. Obviously a terrible situation. So the fact that idempotency is one of the first things that a developer will try to build in the module, that's going to give us a nice, warm, comfortable blanket knowing, hey, we can execute this task over and over and over again, and it won't cause, it won't provide any kind of risk or present any kind of risk for us on the control plane. Now, typically is a good rule of thumb. It comes down to the developer of that Python module that we actually call as the module inside of Ansible. A good developer will make sure that they perform the types of checks. There's ways to achieve that. I cannot guarantee you, if you go out to the third-party ecosystem of Ansible called Ansible Galaxy, I cannot guarantee that it's going to be, everything's going to be idempotent. So just be wary of that. Another really great thing, we talked already about the extensibility, but I want to highlight that one of the strengths of Ansible is that it's based or the user's interface with the YAML markdown language, and it's relatively easy for new developers or network engineers coming into a developer focused role. It's easy for them to kind of get off the ground and running with it. And we showed some examples before. Now, with that in mind, let's talk about one of the weaknesses, and that is the reliance on YAML. So it's a strength and it's a weakness. And what I mean by that is that YAML itself is not a programming language. Don't listen to the memes. YAML is not a programming language. It is a markdown language. And so when you need to perform complex operations inside of an Ansible playbook, things like if you're in the Python world, you're like if loops and for loops, et cetera, you'll start to run up against the limitations of YAML really quickly. And so you'll have to either conform to doing things the Ansible way inside of the YAML, or you'll ultimately, in many cases, after you've worked with the product over a couple of years, you'll start writing your own plugins to actually break out of YAML into Python and then dump the task back into the playbook. I don't have any examples on that, and filter plugins are kind of an advanced topic, so I'm not going to get into them for here. Just know that YAML is a strength, and it's got its own little bumpy warts on top of it. We showcased several examples of where I personally have a problem with some of the vernacular and the vocabulary that's used by Ansible. It's really confusing. Just as another glaring example, when we look a little bit later at Ansible Tower, the execution of a playbook is not called a playbook, it's called a template. And if you didn't know what you were looking for, you'd be looking all over the place, like, where are my playbooks? Where's my playbooks? Well, they use the word template. So it's kind of all over the place. And I understand what they were actually trying to achieve by calling it a template, but the vocabulary can be a little bit confusing for us network engineers. If I said, I want you to edit this Ansible config file, and I want you to enable it to do 50 concurrent tasks against my inventory, you probably wouldn't have thought that the word for that was forks. Probably not. There's probably a better word. I haven't come up with one, but forks is kind of a stretch. And so the vocabulary is a little confusing for those of us network engineers trying to get started. A real big one, though, a real a weakness within Ansible is that debugging errors can be pretty challenging, especially for us network engineers. This can be a difficult construct for us to get into. Sometimes inside of your Ansible playbook, when there's a problem, you'll be presented with a wall of red text, and you'll have to figure out where in that red text is the actual issue. And here's the kicker. Sometimes the actual problem isn't in that wall of red text. So it can be a little frustrating, and it's definitely a learning experience for you as you go through Ansible and you start to figure out how the system works and how it reports errors. You can get better at dealing with errors when they come from the remote device, but it can be pretty daunting right off the gate, and honestly pretty scary. Like if you're doing a network change against, let's say, 10 devices, and when your play executes, you get a wall of red text, you're going to worry that you broke something. You're going to have that like sweaty palms kind of moment, like, oh, what did I do? So I highly recommend to try to get familiar. Fortunately, when you're starting out with Ansible, you're going to make a lot of mistakes. And so you'll get quite familiar with how some of the errors are structured, but just a really quick note that it can be a little difficult. And the last point, we touched upon this earlier, Ansible is kind of at this inflection point. We were on Ansible 2.6 like back in 2016, and we were on 2.9 as of like a year ago. Now we're on 3.3. Like we went to 2.10, 3.0, 3.1, 3. And just like a matter of like a couple of months. So I don't necessarily think that this is a weakness, and that although I have it listed here, just know that right now, as we speak in April of 2021, Ansible is kind of in a big transformation phase. So depending on where you're looking in the documentation, things might not be as you expect them to be. But that's not to say that the project is any buggy or any along those lines. It's just Red Hat is changing their package cadence delivery of how they introduce the product. And so this is that time where things are starting to get ramped up. Let's talk about, first of all, there's a question in the chat. Sorry if this has been asked before, joined in late. Can we execute Ansible playbooks without netconf enabled on the Junos device? You absolutely can. And I would absolutely cry if you did that, please. Please don't. I mean, you absolutely can. It just, I'd have to figure out what's the best way of doing it. On Junos devices, everything that we do from an automation perspective, also from a CLI perspective, is driven through this construct of an API. And as we talked about last week, Junos uses the netconf API for 100% coverage of configuration changes and operation data, control plane data, all that good information like interface counters, et cetera. We go through the netconf API. Now on Ansible, if you did not want to use the API, first of all, you wouldn't be able to use the official Juniper Ansible modules because they are relying on that construct, that API construct to be there. They're actually based on PyEasy, which is our netconf API abstraction in Python. Now you might be able to use some of the default, like I would just call it the lowest common denominator packages that Ansible produces. So know that Ansible is trying to make some changes into the core project to be kind of homogenize the network automation landscape. And the only way that they can do that, like use the same plugin to automate Cisco, Palo Alto, Juniper, Arista, Cumulus, all of the networking platforms. They're trying to boil everything down into a lowest common denominator, and they call that the network CLI. Now, on that network CLI, since we're talking about having to boil down the entire industry to the lowest common denominator, which is SSH, no APIs involved, they use a Python package called Paramiko that will do the SSH and the screen scraping on the remote devices. So I would recommend that if you're interested in bypassing the API, and if your team is okay with just doing raw SSH commands and having to write regular expression parsers to understand the data, et cetera, if you're okay with that, check out the network CLI. It is one of the core project or the core plugins that Ansible actually builds and maintains, and that would probably accomplish the goal. Now, just note, if the problem with the API is that it operates on TCP 830 by default, you can override that API to also work on port 22. So if it's like a firewall issue, like you don't want to allow port 830 on the inbound on your firewall rules, but you already have 22, you can override the default ports of the netconf API to still execute it. You don't have to use 830. You can still use 22, but please, if you have the opportunity, please use the API. This is me talking to my previous life. Please just use the API. It's there. It's wonderful. It's extremely mature, and it'll make your life an absolute blessing. But if you have to boil it down, there are options available in there as well. Let's talk about the right environment for Ansible, because this is an interesting concept. When does it make sense to consider Ansible? When does it not make sense? And so right out of the gate, let me just say, if you're working inside of a team construct, and most of you are on this call, if you're working within a team, Ansible, or really any automation framework, is going to be extremely valuable for your organization. Let's give an example of what it would be like without an automation framework or Ansible to help kind of lay that point down. So if we were just doing everything with Python, and I work on a team of 5 individuals, we're managing 10,000 networking devices through automation. If I was doing this with just Python, I would have my own set of scripts. Those scripts have their own, I have my own naming structure for my functions. I have my own naming structure for my classes. all the things that we build like functionality into Python. I would have my own naming schema. My teammate would have their own naming schema. Another teammate would have their own, and everyone's got different coding styles. Everybody thinks that there's a unique way to do this, and they'll accomplish that goal through those scripts. Now, if I was to leave, someone would need to turn over and manage my scripts, and it would be pretty complicated. Like they would have, depending on the script, I'm not the best coder, they would have to kind of figure out, what is this person doing? What did they call? How did they call that? What were they hoping to achieve, et cetera? It can be really, really difficult as teams start to build out their automation if everybody's doing things in their own individual way. And that's what Ansible really helps kind of bring together, and as well with other automation frameworks as well, is that everyone speaks a common vocabulary. We call things modules, we call it inventory, we call them plugin, whatever it is, filter plugins. Everyone speaks the same vernacular. And so it's easy for other teammates to help support whatever playbooks that you're developing. Or if you're running into a problem, you could bring in another teammate to say, hey, what am I doing wrong? Help me out on this. And then they could easily identify exactly what you're doing and show you a way to actually achieve your goal. So working within a team construct is extremely powerful value proposition of Ansible. If you're by yourself, or if you're like on a team of 2 people and you are seasoned Python developers or Golang developers, hey, maybe Ansible is not going to provide you all the value that that we just mentioned, but typically teams are a little bit bigger than 2 individuals. Another reason to consider Ansible is if your team just doesn't have any interest in learning Python. Like, absolutely not. As soon as they hear network automation, their brain starts to check out. And I completely get it. And I've worked with a lot of teammates over the years, and some of them have had that mindset. They just don't want to have anything to do with automation. And so Ansible is a really great product to select, again, because it's relatively easy to insert in the environment. You're not forcing people to learn Python or Ruby or Golang or whatever kind of programming language. People can generally be handed an Ansible playbook and figure out what's actually doing what. And that, again, speaks to the simplicity within the YAML. Another part, just thinking of this on the customer side, there's times where my lovely CIO or my lovely VP will come to say, hey, we need some kind of network automation. I went to this conference and everyone's doing automation. What are we doing? We need an example. We need something. Show me that you're doing network automation. Ansible is a really great tool for those kind of awkward situations where you just want to say, hey, look, we're doing automation and this is what it looks like, and we're supporting it. So a quick win is always a good thing as well. Ansible is also great if your company has a mandate to get support from a vendor. You're not going to get that type of support from alternative solutions, or maybe you can with SaltStack now that VMware has acquired them. But generally speaking, Ansible has really great support, not only from the paid support that we're talking about in this context, but also the community support is phenomenal for Ansible. That should probably have been on the strengths. One of the biggest strengths is the community within Ansible. If you're running into a problem, there's going to be a dozen people that have already hit that problem on Stack Overflow or Google. Find it and then execute. And the last thing, yes, if you need a web user interface, again, if you're trying to simplify the execution of Ansible or introducing individuals into Ansible, a web GUI is usually a really good tool to be able to be that kind of gateway. All right, so that's it as far as content goes. Everything else today is going to be live demonstrations and Q&A. I'm going to take just 10 seconds to get a breath and drink something. This is a really good time. If anyone wants to pipe up and ask any questions, either raise your hand, unmute yourself, fire away. If you need help with marinating some of the facts that you just learned or just pulled in, and you need additional explanations, let's just take a minute to honor that. I've either got a shy group of 51 individuals, or the content was just so rock solid that there's no questions. And I know which one my ego wants to tell me it is, but prove me wrong. Okay. Oh, here we go. We got a question. got a question. Since Junos modules are written in PyEZ, can't it be run in the traditional way of secure copy and run on the box? That's a good question. So yes, first of all, for your first part of the question, Junos modules, the plugins inside of Ansible, they are built entirely around the PyEZ package that we provide for Python. So can Ansible be ran in the traditional way of secure copy to the remote device and run on the box? And the answer is no, no, it's still not. They're running Python scripts on box on Junos, and the same is true with the other vendors as well, like the guest shell on Cisco devices. There is capability of running Python scripts in this kind of construct of a sandbox. But unfortunately, there are a lot of things that we, the networking vendors, have to do to help secure and lock down that runtime environment on the device. And so we'll put up these walls that will prevent things like you were talking about. It's a great question, and I would love for it to be answered in a different way. I really wish that we could take advantage of that Ansible execution of secure copy the Python script and run it on the box, but unfortunately, it's that functionality just isn't there. So sorry. File an enhancement request with your account team, please, on my behalf, please. That would be amazing. All right, so Jim asked a question. He says, where would run Ansible Tower or AWX? Where would Ansible Tower or AWX live or run? That's a good one. What I've seen is most of the time Ansible Tower is going to live somewhere on-prem, just because of the requirement for it to access internal networking devices. Now, that's not to say that you couldn't run Ansible Tower in the public cloud, as long as you had like your VPCs set up in a way to where you have a private connection from your public cloud into your own local environment, and the public cloud has been blessed to interact with your networking devices. You could probably secure that with some kind of VRF construct or something along those lines. So that's definitely a doable. Typically, it's an on-prem execution engine. Now, in contrast, if I was like in a DevOps world and I just lived in the public cloud and that's all I focused on, that's where I would host Ansible Tower, either as a container or as a dedicated virtual machine, within that VPC or within that cloud construct. So if you're interacting with cloud APIs and everything that you're touching is available on the public internet or accessible on the public internet, maybe that makes sense as well. Ansible Tower and AWX, they have different, or at least last time I checked, the actual package installation is different. Ansible Tower used to be like a package, like a deb package for Ubuntu, or a yum package, or RPM package on Red Hat. But in contrast, Ansible AWX is always ran as containers. It's one of the things I really like about the project, is that it's really, really easy to kind of get off the ground and running with standing up AWX, just because it's built around this construct of containers. Now, previously, or actually, I think it's still the case. AWX was using Docker Compose as like the orchestrator of the Docker containers. And by the way, if this conversation doesn't make any sense, or if I'm losing you, feel free to tune out and go get a cup of tea for a second. But Ansible AWX is delivered through the construct of Docker containers, and they were using Docker Compose as kind of like the default. Docker itself, the company, the product, is in kind of turmoil right now. I'm not going to get into the drama behind all this Docker going away type of thing, but now kind of the default deployment for Ansible is either on Kubernetes or OpenShift, which I mean, I love those constructs, but holy moly, it's difficult to maintain and manage those systems. So hopefully we'll see like Podman or some other kind of Docker Compose replacement be delivered within Ansible AWX. So again, it's easy for us to stand up. Another question we got, what would you pick in the long term, Python versus Ansible for large enterprise network? Just based on the large enterprise networks I've worked at in the past, I would definitely pick Ansible, just because the teammates that I had, everyone was unique in their desire to adopt automation, and everyone was unique in their background with automation. And so, not to boil everything down into lowest common denominator, but if you're working in a team construct, I highly, highly, highly recommend using an automation framework. I'll put my flag on the ground and say an automation framework for many of the reasons that we talked about: inventory, speed of execution, simplicity, et cetera. An automation framework must be picked for a large enterprise team. However, it doesn't have to be Ansible. If your team is seasoned Python developers, give Nornir a shot. Give it a shot. It is a phenomenal project. It's super fast. It's very lightweight. And the people that are developing that project are the brightest in this community. So give Nornir a fair shot if Ansible isn't your preferred flavor. But for everybody else, I would highly lean on Ansible as kind of being the default. It's worth at least exploring Ansible to figure out whether or not the workflow makes sense. If your team is picking it up, et cetera, then yeah, absolutely. I mean, give Ansible a shot. But once you if you start to figure out that, for one reason or the other, you're annoyed with the way it's executed, or everyone's got personal preferences, right? Then at least give Nornir a shot or something else. Alec says 128T. Oh, hi, Alec. Alec, 120T would make it easy for Ansible to live in the public cloud with managed elements across enterprise. Absolutely. Really good point. Absolutely. Okay, Mohammed asks, can you share your Twitch channel? Yeah, I can. The Twitch channel is kind of in turmoil right now. I got banned. Artificial intelligence is wonderful. My content was deemed as spam or something along those lines. My channel got banned. I moved over to YouTube to do YouTube live streams. That's where I am right now. I'll share that information. I'm looking to get back onto Twitch as soon as I get unbanned. Of all the content that gets on there, my network automation was deemed not safe for work or something. I don't really know. But yeah, I'll share my information. I am a sales guy by default, so I like to sell myself. So we'll definitely do that. All right, getting to the, and by the way, great questions, keep them coming. You have the humor to admit that, yeah. Well, yeah, you got to stay sane. Humor is my mechanism for that. Okay, so we got 5 unique automation examples today. One of them is we're going to basically transport a CLI configuration that we would have done manually. We're going to translate that into an Ansible playbook. I want you to understand just how easy it is to take current change control tasks that we're doing and wrap them into automation. So that's going to be our first task. The second one is we're going to be retrieving LLDP neighbor information from our devices, and we're going to write that to a file. And as always, with working with an API, that data is going to come back in structured data format, XML or JSON or something along those lines, which is an absolute blessing, rather than getting like a clear wall of plain text and having to write parsers. So we'll take a look at that one as well. Third one is really interesting because it's not really a networking thing, but it kind of is. We're going to deploy a brand new firewall, a virtual firewall, to protect an application within our data center on VMware. And we're not only going to deploy the firewall itself, the virtual firewall, we're also, after Ansible deploys it, it's going to log in and make configuration changes so that the device is online and operational. Then we'll transition back into the more networking centric stuff. We'll talk about the JSnappy product that Juniper delivers, and that helps us provide the ability to do assertions in the environment, saying, log into the device and assert that there are no errors on the chassis, that there's no problems with the fans, no problems with my OSPF neighbors, that my transmit and receive light levels on my SFPs are operating within the current spectrum, that I've got, this amount of routes from this neighbor. JSnappy is a really great tool to build those network assertions. And one other thing that it can do, actually arguably the primary driver behind JSnappy, is to do pre and post automation checks and validations. That is to say, log into the firewall or switch or router, get an overall snapshot, like what's my MAC addresses in my table, what are my IP addresses in my ARP table, what's the status of my neighbors, etc. Perform this big snapshot, and then perform some kind of change on the device, whether it's like upgrading the version to a new release of code, or maybe we're going to be configuring a new BGP pair, or whatever the configuration change actually is. And then log back in and take another snapshot, and then do a diff in between the before and after snapshots. And if there's any variation in between them, then create an alert, create a report, send an email, send a message to Slack, whatever those types of functionalities is. JSnappy is a wonderful, wonderful tool that can help us help validate the overall health and state of our networking devices. So we'll be showing a little bit of that. And the last one, just kind of the cherry on the top, we're going to build an entire data center today with Ansible, and we'll be showcasing this construct that I branded it, infrastructure as code. We're going to be showing how Ansible can be used in an infrastructure as code format to completely build a full VXLAN EVPN configuration that is perfect, 100% perfect. So we'll be showcasing that. So without any further delay, we're pretty good on time. We might go over a few minutes. I hope that's okay with you guys. Let's go ahead and start our automation journey off by getting out of PowerPoint. There's a challenge within itself. There we go. All right. Now I'm going to be performing all of my automation changes and demonstrations in a product called Microsoft Visual Studio Code. This is, in my humble opinion, the absolute greatest piece of software Microsoft has ever created. And it is also like the #1 favorited program or project on GitHub. It's completely open source. And there's also plugins to help you manage and interpret Junos configurations as well. And one of the things that it provides to us is a text editing construct where we're going to be editing our playbooks, but we can also have a direct terminal so that we can actually execute them as well within the program. So we're going to be using Visual Studio Code quite a bit here. Now, the very first task, or the very first playbook that we talked about, was doing some basic configuration on a remote device. And so let's dig into this playbook. And by the way, all of these are already available online. I'll be sending out a link as promised at the end of the presentation. And within each one of these projects, whenever you go and investigate it, just know that there's a lot of extra goodies that I use in there to help make this execution just a little bit easier. But typically all the Ansible files will be stored in a directory called files and then Ansible. So in this case, configure with CLI commands. Let's go ahead and look at my playbook here. And let's take a little bit of time to just kind of deconstruct what we got going on here. Now, with me, my memory is terrible. So I like to spend like at least half of my playbook on comments so that I have an understanding as to what the heck is going on. Because once you start building these things en masse, you're going to quickly forget. Maybe, and I hope your memory is better than mine. But so a lot of these lines that you'll see here are actually comments that I'm just leaving myself so that I can understand what's going on here. And you'll see those comments, they'll start with a pound sign or a hashtag based on your generation, whatever you want to call them. So let's go ahead and disregard this. This is just a comment that says we're going to configure our device with basic parameters. Okay. Right out of the gate, I understand what's the purpose of this Ansible playbook. Now, again, like we talked about at the beginning, the first few lines of the Ansible play are us kind of tuning how we want this execution to run. which devices we want to actually execute with. And again, overriding some of the defaults of Ansible and then importing the third-party package for the Juniper modules. Now, it's worth noting, we're going to take a look at the playbook. We'll take a look at the inventory file, and we'll take a look at the config file, like we kind of highlighted as the core constructs here. This is the playbook. Let's take a look at my Ansible config file. There's kind of a lot going on here. You don't have to know all of these. Like I said, this is like the default config file I use for all of my projects, and I tune it as I see fit, but I very rarely ever deviate away from this. So what we have here is basically the SSH keys. I'm also saying, hey, execute up to 15 consistent workflows. And I'm pointing to the path for my inventory file. Let's actually look into that inventory file right now as well. So here it looks like I've got a YAML file that's got a single device called Ansible Firewall 1. I'm declaring it's got this static IP address. Just in case your DNS doesn't work, you can overwrite Ansible's defaults by passing in a static IP into this value called Ansible host. That's what you're seeing here. Ansible host is a member of the firewalls group. And the firewalls group is a group of the all group. So when I look back into my Ansible playbook and I say host all, just know that that needs to match something in your inventory. In my case, it matches the all group, which would then subsequently match everything else listed in there. Now, in my case, that's kind of anticlimactic because I just got a single device, but I hope that you understand at least kind of the relationship between the Ansible playbook and the inventory file. So before we actually dig in, actually, no, let's keep going on the Ansible playbook. There's not much left here. Now, my playbook has 2 tasks associated to it. We can see this task section listed out here on line 11. And I've got 2 different things that we're going to achieve. So let's take a peek at what those are. Now, the first task, I have a description for this task that says send CLI configuration commands to the remote device. That again is a comment to myself, but also when we execute the playbook, you will see this line printed to the screen as this text or as this task is being executed. So it helps you kind of understand where Ansible is within the playbook. In this case, if I got 2 tasks, hey, well, where's the value in that? But if I have 20 tasks and some of them are taking a little bit longer than others, I probably want to know what's actually going on. So I leave myself these big comments so that I can understand it. We are calling in the Ansible module called Juniper_Junos_config. Now that is a literal Python script with that exact name stored in a remote directory. I imported that by using this construct of here, roles and juniper.junos. So I'm now calling a Python script from that repository, and I'm passing in some basic parameters. What is my username, my password? And look here, we can actually tune how long to wait before Ansible create or reports that the connection timed out. Here I'm setting it to 4 minutes, which is way too long. You should never have a task making configuration changes that takes 4 minutes. So anyway, there's that little knob that we got. Now I'm also telling the Python, the Juniper Junos config module, I'm also sending it some additional parameters. If you've worked with Juniper in the past, you know that we have these set commands, and these set commands are how almost every network engineer configures a Juniper device, where we want to say set system host name, router 1, set system domain server, google.com, etc. So in that case, we're calling set commands, but you could pass a Juniper device XML. You could pass it JSON. You could pass the config in the standard Junos structure that you see whenever you do a show configuration. So we're telling the Ansible module, we're not going to send you XML. We're not going to send you like the Junos config format. We're actually going to send you some set commands. And when you receive these set commands, we want you to do a merge operation. And again, this is a Junos specific thing. But if you can have it to say only accept these commands and delete everything else that's on the other on the device. That would be an override function. In this case, we're just saying, hey, merge these configurations into the actual config and don't take away anything that that we didn't declare. This is a commit confirmed operation where we're saying if someone doesn't log into this device in 10 minutes and confirm the configuration change, then automatically roll it back. This is that one differentiating factor that most Juniper engineers absolutely love, especially when making remote changes on devices. The ability to automatically roll back a configuration is an absolute blessing without having to do like reload in 10 or anything along those lines. Now we actually define the configuration commands. And if you have familiar with Juniper, you would know that these are the actual configuration commands that you would have typed out if you had built an SSH connection to the device. So let's talk about them very briefly. One is I'm setting the host name of my firewall to router 1. So I'm changing the host name on the box. The other is I'm establishing a domain name for my device. In this case, I'm going to say wolf.com. I'm also creating a loopback interface, and I'm setting it with an IP address of 192.168.1.1/32. We're also enabling LLDP on all of my interfaces, and I'm also enabling spanning tree, rapid spanning tree 802.1W on all of my interfaces as well. And that's it. Now, we're going to take the output of this task and we're going to store it in a new variable called result. Now, you might not do this. You may not want to know what was the change on the device. You don't have to register the output to a variable. But if you want to see exactly what changed, this would be a really important thing. Store the output into an object. This time I'm calling that object result. And then we get to the second task. The second task is where we print the result to the terminal so that whoever's executing Ansible Playbook knows what actually changed, if anything, on that device. We'll actually see that. Now, I'm doing something that's kind of fancy. I'm saying print the result to the screen if there was a difference. If there wasn't a difference on the device, don't print anything to the screen. But don't get too tripped up on that. This when logic is another one of those hurdles that we talked about with working inside of YAML, that if you wanted to do some kind of logic, it's kind of a little challenging. So with that being said, let's now jump into my terminal, and I'm just going to pop this open really quick. The first thing I want to do is make sure that my current Python environment has Ansible installed on it. So we'll say which Ansible, and here I can see that we get a response back. This is my Python virtual environment. This is not going to be a conversation on Python virtual environments. Maybe some other time. Just know I'm in a Python virtual environment that has Ansible installed. But if I didn't have Ansible installed and I wanted to, I would say pip install Ansible, and that will go ahead and download the Ansible project to my computer. If you're on a modern like Ubuntu workstation, you might have to say pip3 to specify Python 3. But as always, I highly recommend that you consider using a Python virtual environment, and there's a lot of great docs on that. So now that I know that I have Ansible on my computer and my computer knows where to find it, let's change into my directory here for Ansible configure with CLI. Okay, and if I type in LL to look at my folder directory, not LL Cool J, just LL. Here I can see, yeah, these files look exactly like this. It's just structured in a little different way. So we know we're in the right project directory. All right, let me change into my files/Ansible where all my where all my Ansible goodies live. And does that look like it's about right? Let's say inside of Ansible, yeah, we got a roles directory, an Ansible config file, and the actual configuration. So before we do this, let's open up another session to the device just so that you know I'm not kind of pulling any smoke or mirrors over anything. Let's SSH into this device right now and make sure that its configuration is not like we're going to be doing to change it. So let's go ahead and, yeah, sure, select that and SSH as the root user to this IP address. My password is Juniper123. Please don't hack me. All right, so here we see we've got Ansible Firewall 1. And if I say show configuration protocols, right? This would be like my rapid spanning tree, my LLDP would go here. I get nothing back. If I say show configuration system host name, well, you might not be too surprised to see that the host name is currently Ansible Firewall 1. And if we say system domain name, we get nothing back. Okay, so that we know that what we described in our playbook is different than the current state on our device. What would it actually look like if we executed this Ansible playbook? All right, so I'm going to call Ansible by saying Ansible -playbook. And yes, that will get very tiring to type out every time. You'll probably look to making some kind of shortcut. I always encourage that shortcut to be inside of a Docker container, but you could use Python or Invoke or any of those other constructs. So I'm gonna specify the name of my playbook next, which I always start my playbooks with the letters PB. This is just my control freak behavior. When I'm working in a directory that's got hundreds of files, I want to know exactly where all my playbooks are. So I start the naming structure off with PB. Now I need, actually, let's see. What's the Ansible config file set for my inventory? It looks like the inventory file is set, so I don't need to declare it now within my playbook. So let me clear the screen and say Ansible-playbook pb configure.yaml and then execute. Now, I told you that I had coded some problems, or there were some problems that I was going to showcase here that we needed to break into the Ansible config file to work through. And this is the first one. So already on our very first Ansible playbook, we're getting some kind of error into the screen. We got the red text. Okay, what's going on? This is a big annoyance that a lot of us have in working with Ansible, is that Ansible really struggles to work in virtual environments. It always wants to default to your system's Python version. And if you didn't know what you're looking at, let me explain to. When I'm issuing this playbook, Ansible is telling us you are trying to run a plugin that requires the Junos Easy NC package, which is Juniper's PyEasy package. But it's saying we cannot find it. It's not installed in this Python environment. So what we have to do is we need to break into that Ansible config file, and we need to override its defaults to say where our Python virtual environment really is. So the way that I do that, again, I'm going to type in which Ansible playbook, and then I'm going to say, okay, this is the directory of my virtual environment. I'm going to copy this to the file, and then I'm going to come back to my Ansible config file, and I'm going to make an adjustment by uncommenting this out. This is the path for my my Ansible Python interpreter, or for my virtual environment. Sorry, I showed you the wrong way of doing it. You should have typed in which Python and then just copied the actual full path and text and then placed it within here. Make no mistake, you will run into this problem at some point, and you'll be pulling your hair out because you're thinking, I know the Junos Easy NC package is installed in my virtual environment. What is going on here? So just know that this is a big annoyance with Ansible, and one of the reasons why I highly recommend always using Docker. And I always provide Docker files in my projects so that you can use that rather than dealing with these annoying realities of Ansible sometimes. So now that we've specified, we've overwritten the defaults inside the config file and told it where to find our Python virtual environment, let's go ahead and execute our playbook. So we see that it's taken just a second. We're sending all those CLI commands to the remote device. And now let's actually interpret what we got back. So starting from the top, the play is all. This is saying again at the very top, I didn't pass in a name for my play, so it's just defaulting to my inventory device. Now we get to the task section. Remember, we had two different tasks. The very first thing was to send CLI commands to the remote device. We got a yellow indication coming back from the device to say something was changed. There was a change on the device. Now, if you remember, we told Ansible to register all the output of our changes into an object called result and print it to the screen. And that's what you see in the second step here. We're actually printing it out to the screen. And what's great about Juniper, and for all of you guys that already have worked with our devices before, you'll know that you'll get the diff. You'll get exactly what changed on the device. So pluses and minuses indicate what kind of operation was performed. Here we can see that the hostname Ansible Firewall 1 was removed and hostname router 1 was replaced, and all the other configuration parameters as well. So let's jump back over into our device, and I'm gonna hit the enter key just once. And what we get right away is we get a message to say that the commit confirmed will automatically roll back the last change if nobody commits this change in the next 9 minutes. We also see that the host name has changed from Ansible-firewall-1 into just router 1. Now, if I say, show me the configuration of my protocols, I can now see that we've enabled LLDP on all of our interfaces, and then I've enabled RSTP on my virtual firewall, which is already not supported, but it still let me do it. So there we go. So we know that the configuration took place. And if I look for that domain name, yes, I get the domain name back as wolf.com. Now, I told you that these modules are idempotent, and that, well, typically, if a good developer wrote them, they're going to be idempotent. So let's say I want this playbook to execute every hour on the top of the hour, but I don't want it to make a change if the change is already present. Let's show you what that would actually look like right now. I'm going to hit the up arrow and execute this again. And this should not take nearly as long. We see now that we didn't get a changed value that came back from the device. We just got the thumbs up okay, meaning that no changes were done here. And remember, inside of our print statement, we said only print to the screen when there's an actual diff. In this case, there was no diff because the change was already present on the device. So that play or that task was skipped by Ansible because of that. So again, we didn't need to make the change on the device, so no change was actually executed on there. So really great. We know that we can make configuration changes, and we can do it quite easily just by porting the same commands that we would be doing already from the command line. They can be easily enveloped and ingested into the Ansible execution. Now let's move away from the CLI configuration changes and talk about that second one, which was retrieving LLDP information. So I'm gonna dig into this playbook just a little bit, but I'm gonna put on my Micro Machine Speed Racer voice because we are gonna be running out of time here, and I wanna make sure everybody gets the full experience of all these demos. So let's just tug into this one. The differences here is I'm creating some variables inside of my playbook. This is not a, you may do this in different times, but there are dedicated directories to hold variables. In my case, I'm storing my username and password, and I'm also creating a variable called backup directory, and I'm telling it exactly where to find this folder in the context of my project. Now, you can note that this directory right here called output is effectively empty. There's a file in here called getkeep, which will it's an empty file that just lets the project be stored in the source code, or lets that folder be maintained even if there's no files in the project. Let's go ahead and check out what it's like to receive the LLDP information from our devices. And to do this, I'm going to back out just a little bit and change my directory to retrieve LLDP neighbors information. We're going to change into the files and Ansible directory. And yes, these files and folders look very similar to what we got here. So we think that we're in the right world. Let's look at my Ansible config file. Again, I got a single device. It's in a group. This one's just called Colo Router 1. I have a static IP assigned to it. All right, so what we're going to do is we're going to execute Ansible Playbook. And we're going to point to the, actually, this might have the same Ansible config issue, and it's going to. So let's go ahead and copy what we did for this one. Let's copy that config line into here, or else we're going to have a Python interpreter error again. So let's go ahead and paste this. And again, this is something, this Python environment issue is only found with, like, if you're executing Ansible in the command line. If you do this from Tower, you're not going to run into those types of problems. There's another value of Ansible Tower. So Ansible Playbook, we're going to say pb.retrieve LLDP.yaml. What this is going to do is it's going to log into my Colo router, and it's going to grab all the information from my LLDP neighbors. And if you've got a sharp eye, you would note that this file was just generated. Before we dig into that, let's actually look at the output that we have here on the screen. We can see that we printed the result of the screen, and the Ansible module is really nice in that it will structure the output in different capacities. So the actual format that the data came back was in XML format, and that is definitely there in this output as well. But Ansible, the Ansible module will also present it in YAML structure as well. So if you're just looking at this and you're saying, what was my neighbor on gigabit 001, rather than going through the wall of XML output, you could just say, okay, that one's 013, 012. Oh, here's 000. The neighbor was Dallas Firewall, and here was the local interface for it as well. And here's the remote systems MAC address. And we can see that we actually wrote this output to a file here called colorouter0.json. And if I use the Visual Studio Code plugin to format this document, it'll actually format the JSON for us. So we can see the data is presented, and actually in this case, it's written to a local file. If you prefer XML, I don't blame you. It's a great protocol. It's a great markup language and a great protocol. Here it is in XML. This is the native Junos data format is in XML. If you prefer that, you're more than welcome to. And it even presents it in a string output if you wanted to actually write regular expression parsers, maybe because you're a sadist or something that you'd rather do things the really, really hard way. You could actually parse the text string yourself as well. So there, great. We showcased how to use the Ansible modules to actually retrieve information from our devices. Let's move over into the Ansible Tower side of things, where we'll do the deployment of a new virtual SRX in our environment. So I'm going to log into my Ansible AWX. And from here, I've got a list of different templates. Now, remember, in the construct of AWX and Tower, template, think playbook. It's technically a little bit different because a template has a little bit of flavor on top of it. But ultimately, these are going to be our Ansible playbooks. And I can dig into any of these playbooks and figure out exactly who did what on what devices and what actual changes were actually executed. But in reality, I want to showcase the API functionality of Ansible Tower, because I think that's going to be the really compelling thing. So what I'm going to do, instead of executing something from Ansible Tower, we will see it executed in Ansible Tower, but I'm going to use another abstraction. I'm going to actually use ServiceNow to instantiate this new virtual firewall. So go ahead and log in with my super secret password. I have a ServiceNow instance where all the home of all my network automation is instantiated from. So whether I'm doing changes on the Wi-Fi or data center or security, or whether I'm upgrading a device, I can issue all of those commands and task and request through ServiceNow, and then ServiceNow will make the API call to Ansible Tower to actually execute. So let's figure out how difficult it is to deploy a new virtual SRX inside of our data center. I'll click on security. I'll click on deploy virtual SRX. And I see that I have one form field that's mandated or required of me, and that's the name of the virtual SRX. And I don't know, what's a random word, just so that you know that I'm not making random word. I'm just a little paranoid that you think I'm blowing smoke and mirrors. What's a random word generator? And this is going to be our host name. Outmantle. Okay, that is a new word for me. Let's go ahead and paste that here. So my firewall's name will be Outmantle. I will select the appropriate Juniper virtual firewall version, which in my case, I live on the bleeding edge, sir. So we'll go ahead and select that one. Select which ESXi host, I'll keep it on the default. Select which data center, keep the default, and select which services are required. I've got a web server, Ansible server, it could be Postgres. This would actually affect the firewall policies that are created and which interfaces those policies or security zones those get applied to. So think about like this just for a second. I'm going to click the order now button. And from that perspective, my job would be done, but I do have an additional step where I'll go through this approval process and we'll say, yes, that looks legit. Let's go ahead and sign off on this change, and then we'll execute our Ansible playbook. But think about like just how easy that was, and think about turning over the deployment of your virtual firewalls to like an application developer. They would just go to like a ServiceNow portal. They don't know that it's a firewall. They don't know it's a Juniper device. They don't know what security policies even are. They don't know that it's going to VMware. they don't even know that it's using Ansible in the background. All of that is subtracted from the equation, which enables you to deliver like self-service portals for your customers, which are ultimately your application developers. And so here we can see Ansible Tower's got a new deployment that's being executed. We can drill into this detail. If I move over to my, we're going to miss it if we don't look right here, into my vCenter, I can see that a new firewall is being instantiated. The execution time looks to be off. Yeah, looks to be off by 20 minutes or so. But we've created a new firewall called Outmantle. And if I look over here, there's the Outmantle firewall. We can see it's currently coming online. Okay, so as that firewall boots up, that's not the end of the playbook. It's actually also going to log in and make basic configuration changes. And so we'll keep this on in the background. It'll take a couple more minutes for us to execute, but let's return back to our next automation example in the meantime, which was using Ansible and JSnappy to perform state validation on our devices here. So I'm going to clear my screen and change back into a different directory that I've got listed here. This one's going to be OSPF. There we go. JSnappy OSPF validation. If I open up this directory, let me just go ahead and close everything else. If I open up this directory, let's take a peek at the Ansible playbook here. The Ansible playbook says the same things that we've been doing before, defining how to execute the Ansible playbook. Again, I'm passing in some variables. You would probably want to secure your variables a little bit better than I have here. And let's look at the actual task. We've got 1, 2, and 3 different tasks that are here. Let's take them apart just really quickly. The very first tasks that we have is we're calling a Python script in the background. It's called juniper.junos or underscore JSnappy. You don't have to know that that's Python. You don't have to know anything about the code that's actually executing, but you and I know, right? We're in the know. That's a Python script. There's a literal script on the device on this Ansible server that's got that name, and we're referring to it right now. And then we're going to pass in some parameters into that script: the host name, the username, the password, the types of things that we would need to build an SSH connection to the device. We also declare our test file. Now, this is a JSnappy construct, and we'll get to that in just one second. But we're issuing JSnappy, which again allows us to make network validations, assertions. I'm passing in a test file. What are the things I want you to do, JSnappy? And we'll take a look at that just in a second. There's also this action of a snap check. Again, JSnappy works in 2 different ways. One is a snap check like I'm showing you right now, where we log into the device, take a snapshot, and compare it with the test that we're passing. But you could also do the other aspect of JSnappy, which is pre and post configuration change and state validations. So I'm going to only be showcasing one of those here. We're storing the output of our test into a new object that we call test_OSPF. I'm also telling Ansible, ignore any errors, meaning like if the test fails on a device, if the result was a failure, just ignore it, just carry on. Don't stop the entire Ansible workflow just because of that error. Don't worry so much about the tags. It's not important in this construct, but basically you can add a tag to a playbook and use that as a reference point later on. The second task that we have, we're going to print the output of our JSnappy test to the screen. And then the third task, we're going to build an assertion. We're saying, thou shalt must be at 100% pass percentage. If any of the tests came back that were a failure, obviously you wouldn't be at 100% validation, and that would be indicating that there was a problem. So we talked about the JSnappy test. Let's actually take a peek as to what that actually looks like. So if I go into my folder directory, it looks like my folder name is test. There we go. And it looks like I've got a file called OSPF that I'm referencing. Let's take a peek into that. This is going to be the actual JSnappy test that we run. Now, my test has 3 separate unique tests. And what I'm doing is I'm running a command, show OSPF neighbor, and then I'm pointing to that neighbor's IP address. And then when the JSnappy gets the output of this command right here, then we use the XML XPath And that's a whole other conversation. But just know we're going down the output. We're using the XML that I've got listed right here to find what value that I'm looking for. In this case, I'm looking for the value of OSPF neighbor state, and I want to make sure that that neighbor state is in the full adjacency. It's not in two-way, it's not in a init, it is in a full adjacency. And if there's not, we're going to print an error to the screen to say exactly, hey, this firewall on this interface is in a different state, and we'll actually present that state. Now, JSnappy, you don't have to be as static as I've typed in, like literally the exact host. We could have done just show OSPF neighbor and got a list of all the hosts and then iterated over that. But I just kind of wanted to show a rather easy to, hopefully an easy to understand execution. So with that being said, let's return back to our terminal here. Let me clear the screen and I'll type in LL. And then from here, I know that I need to move to my Ansible directory, and I'll do LL again. And from here, I can just simply say, well, I don't have an Ansible inventory file. Let's take a look at the config file here to see. The config file has the interpreter set correctly, and the inventory file is also, oh, no, it's, am I in the wrong directory? Is that's going to fail, isn't it? Where is my OSPF? There is no inventory file. It's actually back in here. So I don't think this is going to execute correctly. Let's figure this one out. Let's go ahead and try it. We'll do it live. So Ansible playbook pb.jsnappy OSPF. So, okay, this is what happens when the Ansible playbook cannot find your inventory file. And as I said earlier, this is one of the things I always specify inside of my Ansible config file where to find my inventory file. But in this case, it was not the inventory file that I referenced. It was not in this directory, so that we get this kind of output that it says to the screen. Now, rather than editing my config file, I can also pass in an argument, a -i, and tell Ansible where to find my inventory file. In my case, it's in a different directory called Docker, where all my Docker stuff is, and there's my inventory file. So, okay, let's go ahead and execute that. Then we're going to go ahead and see that we're logging into the device, and we got 100% of our test back, and everything is good. And how do I know that? Well, what we see in the recap, we see OK is equal to 3. We saw nothing was changed. We saw none of the devices were unreachable. Nothing failed. Nothing was skipped. Nothing was ignored. So everything came back good. Everything's hunky-dory. And let's take a peek at our actual task as they execute. Again, as we talked about, we had 2 tasks, actually 3. The first was to grab all the OSPF neighbors within the device, and validating them with the JSnappy test. The second, where we actually print that result of the test to the screen. This is beneficial for you and I, as we can actually see this the output here in the screen, and it tells you right off the bat 3 of your tests passed, 0 failed, which resulted into 100% pass percentage. Here's the name of this specific device, and here's the actual output from the command. So for the first test that we ran, 190.221.165.1, here's the result. The result was a pass. The expected was a full adjacency. The actual from the device was a full adjacency. So your test had passed. And it will also show the interface and the OSPF state. And it says that for each one of ours. Let's actually break this, though, because that's when things start to get fun. So I'm going to go ahead and open up a new terminal. We're going to SSH into this device. What was the IP address of my firewall? I'm still in the wrong directory. JSnap, there we go. So this was my IP address of that router. Let's go ahead and SSH into it. Automation at this IP. Pass in my super secret password of Juniper123. And we can see here that we are show chassis hardware. Just kidding. We are an ACX 1100 router that I'm using for my MPLS backbone here in my house, because it has no fans, and I just love that. Okay, so let's go ahead and take a peek at my show protocols OSPF. I'll just say display set. It looks like I have OSPF enabled on 3 physical interfaces. Let's go ahead and disable it on interface gigabit 103. And the way I'll do that is I'll actually deactivate the physical interface itself. So the configuration will exist in the OSPF stanza, but my physical interface is going to have its entire configuration deactivated. So show compare. Okay. And if I just take a look at that interface, just so that we know what we're looking at here, it looks like I'm setting MTU and IP address and as MPLS. Well, we deactivated that configuration as soon as I type in the word commit. And as soon as that commit goes through, we'll go back and we'll rerun our JSnappy test to see what does it look like when we have a failure from our network assertion test. So there we go. It's committed. Let's jump back in over to here and we'll hit the up arrow and execute yet again. And what we'll see now, or what we're hoping to see, is that we actually have a failure on the device. So let's take a peek at what that actually looks like. First of all, our assertion failed. Since the test didn't come back as all pass, we know that there was some issue within the test. And by the way, like I said earlier with the results, you can take these results that I'm showing and you can send them to Slack automatically. You can send them to Teams. You can send them to Facebook Messenger if you really, really want to. It doesn't have to be here within the console itself. But let's take a peek at our results. We see total failed was 1, total passed 2. We have a total of 3 tests. Let's find the failure. Let's see, test results. This one was expected as full. Its actual was null. So this is our failure right here. So 2 tests passed. Okay, so this one was a failed. So rather than being in the full adjacency, it's actually a null adjacency, meaning there is no OSPF neighbor on there. So this was the interface that had failed, whereas this test had passed and this test had passed. So just like that, we can quickly build scripts that can validate the state of our devices. And it doesn't have to be like control plane stuff, right? It doesn't have to be OSPF. It could be chassis alarms. It could be fans. It could be optical light levels. It could be errors on the interface. Whatever thing that you're looking to capture and you want to build a test around, JSnappy is a wonderful utility, and it can easily be inserted into the Ansible project itself. Now, let's check in on our friendly firewall over here. We'll see that when it first booted up, our Outmantle virtual firewall's name was VSRX template. If I hit enter and I log into this, let's see, root and Juniper 123, I can see that the host name is actually Outmantle. And that looks great. So we see that the host name was actually changed. We didn't just deploy the virtual firewall. We also made some configuration changes. If we go back to the Ansible Tower output of that, we can actually see those results right here. And what's great about Ansible is that they'll try to collapse the screen so it's not too much output in your face. I think they give you like 20 lines of output, but you can dig into this and actually figure out all the parameters that actually of that play. So here we can actually see that we instantiated the virtual SRX, and we have another play down here that logged into that virtual SRX after it was deployed, and then we made some configuration changes. And now you get those configuration changes in your screen. Now, since this is in your audit log, it will always be here. So fantastic. So we know exactly over the life cycle of this device, how long, first of all, who provisioned it, what basic parameters were pushed onto it, and all the configuration changes that would take place through Ansible. We can get that historical timeline, and so that if we ever needed to roll back, we would know exactly how far we need to roll back. Now, the last one is my favorite. It's the icing on the top. It's the cherry. It is building a full VXLAN EVPN data center. Now, just to make sure that I'm not blowing smoke, when we're starting from scratch, let me log into one of these devices and say show configuration display set. This is the current configuration on my device. If you've never seen Juniper and you start to get a little nervous, don't worry. Let me just tell you, this is basically me creating a username, me enabling netconf and SSH, and then providing a static routes so that I can access it, and an IP address on the management board. That's it. Not enough for a full VXLAN EVPN configuration. I promise you that. And it's the same across all of our devices. I actually have an Ansible playbook that bootstraps this entire data center for this use case. So let's just log into the spine switch to say show configuration display set. Yeah, super simple. Show BGP summary. BGP is not running. Show LLDP neighbor. LLDP is not running, right? Show interfaces. Come on, Calvin. Show configuration interfaces. Just my EM0, my EM1, my management, and my connection between my control plane and forwarding plane. So this data center is not operating. And because of that, if I logged into one of my devices, we'll say Dallas server 1 over here, and I tried to ping another server on this side, which is Dallas server 4, the servers are configured correctly, although they take a second for me to get a GUI into them. But I cannot ping my default gateway. I won't be able to ping north-south, and I won't be able to ping east-west. This data center is broken. It is in the, well, I mean, it's in a I would call it like a bootstrap state. So IPA grep inet, what's my IP address? Okay, so my default gateway is going to be 10.2.9.1. I cannot ping my default gateway. And let me try to get the IP address of this device also connected over or it's supposed to be a stretched L2, but currently doesn't exist. So IPA grep inet. Okay, so I'm .14. So can I ping .11? Ping 10.2.9.11. Cannot ping it. Things are broken. Can't even ping my default gateway. So let's just go ahead and keep these devices operating in that capacity. So everything's broken. All right. So what are we going to do here? In this case, we're going to be using Ansible, but with the construct or the concept of infrastructure as code, which means that all of my configuration elements are managed as code within an Ansible project. And so let's actually kind of pull this apart just a second. This will get a little complicated because this is an advanced topic. And I hate to berate the complexities things sometimes, but it's kind of cool. So in Ansible, like I said earlier, you can define variables inside of your playbook, and that is perfectly acceptable, although a little suspect at times. It's not really the best for your security posture to be hard coding your username and password into the playbook. But there's also predefined places to store variables. And think of a variable like a host name, a loopback IP address, a interface name, description, any of those things that we would be configuring on a device. Think of that as a variable. And so there are predefined places to store these variables. We can store them at the host vars level, meaning every device has a folder, and inside of every folder, there's a file that has that device's variables. In this case, I'm looking at Dallas Leaf 1's physical interfaces, but there's no Juno CLI. This is all defined in YAML. What's going to happen when we execute this playbook? The Ansible will reach in and grab all the device's variables that either came in at the host level or at the group level. And it's going to say, okay, I got all these variables. Now I'm going to run them through a Juniper template engine, which is going to be based on Jinja 2. And it's going to build the entire configuration for each device and then push it to those remote devices. So let's showcase what this actually look like here. Let's exit out, and let's back out of there as well. Is it there? And demos and Dallas? Wrong one. We were close there. Okay, and let's pick on the Dallas. No, a CD VXLAN ERB Dallas. All right. So we're going to be deploying a VXLAN data center and an edge route bridge topology, and we're going to be using Ansible for this task. All right, so if I look in my directory here, let's go ahead and jump into my files, my Ansible directory, clear the screen again, do the llcoolj command, and I've got a few different playbooks. Again, I use PB to help me point to my playbooks. I've got 4 different playbooks here. One is going to build the configurations. One is going to apply the configurations. And if I'm in day 2 operations and I just want to do a diff, if I want to find out what has changed from the golden configuration, I can use this diff playbook. And here is that other playbook that I mentioned that basically defaults the config to exactly what we were working with here. So in our case, we're going to be working with the build playbook, where again, we build every single stanza of every single configuration based on the variables stored within the Ansible project. And then we're going to run the apply playbook, which is ultimately going to push it. So let's figure out, how do we generate tens of thousands of lines of configuration and push it to our devices successfully 100% of the time? Let's go ahead and work through that. Let's say Ansible playbook. I'm in the right directory. I am. Which Ansible? Make sure. Okay, so Ansible is not found. I need to activate my Python virtual environment. Ansible bin activate. Okay, let's try this again. Ansible playbook pb configuration.build. All right, there we go. And now what we see is we're going through, and again, we're building the apply groups, we're building the system stands, we're building the interfaces, we're building the protocols, we're building the routing instances, the routing options, we're building the VLANs for every single device configuration. And we build each section as its own individual file. What's actually kind of lit, you can actually see this taking place in the live. You'll see files being added here as we see. Yeah, so files, different files are being constructed, right? So here's like my interface configuration file. Here's my SNMP configuration file. Here's my system stanza configuration file. And at the end, like Voltron, it'll symbol all those individual files into the actual golden configuration. Let's take a peek. Okay, so it looks like that was successful. So right now, all we've done is configured the actual, built the configuration. Let's look into our complete folder here. And I can see, yeah, Dallas Leaf 1. Here's my full configuration. And isn't that glorious? Look at all that Juniper glory with this configuration. It's just so beautiful. Like I mentioned, Visual Studio Code has Juniper plugins that help text in a Junos config kind of pop out so that you can understand what is actually what. So, okay, so we just generated 430 lines of config for this one file. I can see my leaf configs as well, and my spine configs. Okay, so we think we're in a good spot. This looks like a legit VXLAN EVPN configuration. Let's go ahead and apply it now. So we'll just say, we'll run the same command, except we'll change from build, we'll change it to apply, and we'll go ahead and press the enter key. And we'll see exactly how this execution takes place here. So while this is going and pushing to the remote devices, let me just first thank everybody for staying an extra 15 minutes on this. I do get a little carried away and sometimes a little bit too deep on certain things. So I apologize for going over on time, but at least I hope it's been a little beneficial to this. These infrastructure as code concepts that I'm showing in this demo, again, these are being implemented by teams that are well along the journey. They don't want to type in CLI commands. And in some cases, customers that have multiple vendors, they don't want the CLI hard-coded on their device inside of their playbooks. They actually just want to store the configuration elements as YAML. And then all they need to do in theory is run the same playbook against a different vendor's template. In this case, I'm running it against a Juniper template, which produces a Juniper config, but you might want to run it against a Cisco template or an Arista template. Just kidding, those would be the same. A Cumulus template, etc. The only thing that changes is the actual template. The variables are consistent across the platform. So here we see the configurations actually being applied to the devices. It looks like it's in a serial fashion. I assure you it's not. What's actually happening is my virtual machine host is overwhelmed at the moment, and these virtual networking devices are taking a little bit of time to actually commit their configuration to here. But after this last one applies, which should be Leaf 1, as soon as it applies, we'll get this wall of green text. This is, again, the diff that's produced on our configurations. We can actually see what things had changed. In this case, we got a lot of things being changed here. We got routing protocols created. We got routing instances. Looks here, we subtracted those static routes that I had on the device. So we're making all these changes. Now, if we return back over into our live demonstration, oh, look at that timing. I just couldn't have timed that any better. So Dallas Leaf 1 was the last one to come online. And that's what this server is connected to. But man, that timing, I really nailed that one. I'm pretty proud of myself. It's taking time to build the L2 adjacency across my data center. There we go. Now we got L2 adjacency built across my data center. So we can see Dallas server 1 is pinging a server and on Dallas server 4 on the same local subnet, despite the fact that they're separated by layer 3. I think I'm using ISIS in the underlay. I don't really remember. But again, we just provisioned a full data center completely from code. And if I said show BGP summary now, yeah, we've got some established BGP adjacencies. We see we got 2 VRFs. I was showing somebody this last night. We were playing around. I call it the Chuck E. Cheese VRF. Sorry about that. But the real VRF is the Dallas VRF listed here. We can see the routes. We can see that we have adjacency. I can say show Ethernet switching table to look at my MAC address table. And I can see that my remote neighbor 2.9.14 was learned over this VXLAN VTEP. And here's the source loop back of that. So we have layer 2 adjacency. We can switch Ethernet frames across a layer 3 overlay by using the VXLAN technology. So with that, let me see. I got a question in here. Let's see. Liz loves the Voltron reference. Yeah, it's an old joke with mine. I always use it, but I'm glad that you enjoyed it as well. So yeah, Voltron. So our configuration, our data center is completely consistent. And just as you would imagine, if we went through and we applied this again on our devices, there would be no changes to be made here for 2 reasons. 1, the Ansible module is definitely item potent, but 2, just like you would notice if you were managing a Juniper config through secure CRT or PuTTY, if there's no changes in the show compare, if there's no diff, then no change will actually be committed to the device. So that's what we're going to see here. Instead of seeing these changes like what we saw here with yellows, we're starting to see the devices come back with a green saying, hey, no changes were actually necessary for this. And so now we could execute this playbook every single hour on the top of the hour to ensure that our data center is running the exact golden configuration. You can even then abstract it into what we talked about earlier by using ServiceNow. You can now abstract it into ServiceNow and enable your developers or enable your data center teams to build these data centers by simply issuing your Ansible queries through a construct like Ansible Tower, where we can actually enforce the golden config. Or if you'd rather go down the Apstra route, you can absolutely build your blueprints and execute them from here as well. Okay, so yeah, we got no diff. No diff was presented, so no diff was actually printed to the screen. We could issue this over and over again. There's the item potency, so check. We feel confident that we are now certified JNCIE for data center, and we need to update our LinkedIn, and we're off to the races. So just real quick, I do recognize we're 20 minutes over. Again, thanks for your patience. Where to go next on this? First of all, if you want some hands-on live interaction, my first place to point you towards is NRE Labs. This is the most amazing network automation platform in the world. It's completely ran within your browser, requires no email to sign up, no registration, no login, no browser tracking cookies or anything like that. We don't even put our name on this product because we don't want people to think that this is a Juniper only thing. NRE Labs is a place for you to execute and learn automation within your browser against virtual networking devices. And the curriculum is provided by the community. In the case of Ansible, Ansible actually wrote the NRE curriculum that you can follow, and you can see the curriculum in your left-hand page, and then you can execute it on your right-hand page inside of the browser terminal. Absolutely amazing product. I highly recommend for anything that you're trying to do in automation, start with NRE Labs first. And then if there's something missing, then go elsewhere. Also, Juniper VLabs, it's another on-demand lab environment that can be spun up within your web browser. No software required on your computer. The only thing you need is a Juniper account, and you're off to the races with VLabs. You can not only just test Ansible and Python, but you can also learn things like how does BGP work, how does OSPF work, how to build a layer 3 MPLS VPN, those types of things, because you're working with live Juniper equipment inside of Juniper VLabs. Again, free, highly recommend it. As far as Ansible documentation in the community itself are bar none one of the biggest benefits of Ansible. The documentation is outstanding, and it's held to high standards, and it executes every time. So highly recommend checking out the basic Ansible documentation. The last thing I'll just mention, all the code that I showed today, that I executed today, and much more is available on my private, my personal GitLab instance. Here's the hard way of getting to that. Oh, just kidding. Here's the bit.ly as well. And if I was a good scout, what I would do is I would copy this right here, and I'll paste it inside of the Zoom chat so that everybody has access to it. There is, again, these examples and much more. I even have a multi-vendor example in there of validating OSPF neighbors on a Cisco device and a Juniper device within the same playbook. So highly recommend checking those out. Feel free to download them, kick the tires and everything on there. They're just examples, and it's just me building them. So if there's problems with them, don't call JTAC. Call 1-800-CALVIN, and I'll get on the phone with you and help you work through them. With that being said, again, almost 30 minutes over. Thank you all so much. I really enjoy doing these with you every month. We're going to continue uploading them to YouTube. Unfortunately, right now, I'm still this is still kind of like a skunkworks operation. I haven't involved marketing just yet. So all the YouTube is on my personal YouTube channel, which, by the way, is where I also do all my live streams that we mentioned earlier. If you want last month's introduction to NetConf and REST APIs, it's right here. Introduction to Ansible and Nornir, if you want to see kind of how both of them work. If you're interested in XML and JSON, if you just want to learn Python, looks like a lot of people are wanting to learn Python, go at it. This channel is here for you guys, and this is where you'll find this video also uploaded. I will paste the link to my channel. I guess I'll just, we'll just paste this into the chat as well, and hopefully that's beneficial to you all. So again, thank you for your thank yous. I appreciate that. I'm humbled. I'm glad it was beneficial to you all, and thank you so much for hanging out way past our allocated time. If you have something specific that you would like to see next month, please reach out to me. My email address is also going into the chat. I believe this chat's going to go away as soon as I hang up the phone, so grab this stuff while it's here. If you would like to recommend some kind of content, feel free. That's my work email address. I check it like twice a day at best. Oh, ouch. But I will try to definitely steer the next conversation toward that. I'm thinking about doing either an introduction to Python for the next module, which, by the way, is already here on my YouTube channel. So it would be easy for me to copy and paste. I'm also thinking about maybe doing a network source of truth, because that's a really important part of an automation stack and worth knowing, at least, the value proposition it provides. But again, it's open to your determination whether or not you have something specific you'd like to see. So feel free. This email address that I posted in the chat, that's also the official complaint channel. So if you didn't like this presentation and you just didn't like my delivery, only email that person. Don't email the corporate, please. So just kidding. That being said, Thanks, everybody. I really appreciate it. It's been a wonderful 2.5 hours. This will, again, be uploaded to this YouTube channel that you see in the background here. And we'll see you next month. Remember, it's the last Thursday of every month. And so that's hopefully to just kind of give you a break from your traditional work stuff, because you guys have earned it as well. Thanks, everybody. And we will see you next time. Have a good day.